Today we're starting Unit 9, Day 1, and the section is titled Ratio and Proportion, and I just want you to know that this goes along actually with Chapter 8 in the textbook, so that's why I don't have a section number listed here, because all of Unit 9 follows Chapter 8 in the text. So a couple of definitions to start. A ratio is a comparison of two numbers by division. So if someone were to say the ratio of A to B is A over B, it can be written, it looks like a fraction, or it could also be written using a colon. So you see here A to B, that's how that's read here at the bottom. We always reduce if possible, so a ratio of 6 to 8 is simplified to 3 over 4. And also, if you're going to compare ratios or compare terms, they must be in the same units. Also, a proportion is an equation that compares one ratio to another. So, for example, if the ratio of A to B is equal to the ratio of C to D, then the following can be written. A over B would be equal to C over D. And the two other definitions here are extremes and means. So A and D are the extremes. So the top of the first ratio with the bottom of the second, and B and C are the means. So the bottom of the first and the top of the second. So we have a couple properties of ratios. The first property is one you're very familiar with, is the cross product property, which says that the product of the extremes is equal to the product of the means. And we know this as cross multiplying. So if ratio AB is equal to the ratio of C to D, then we can multiply A times D and set it equal to B times C. And we know that as cross multiplying, and we'll do a lot of that in this section. We also have the reciprocal property, which states that if two ratios are equal, then their reciprocals are also equal. So here you see that we have if A over B or A to B is equal to C over D, then their reciprocals, B over A, would also be equal to D over C. So if we look at some examples, we're trying to decide if these ratios are in fact equal. So for number 1, we have 3/5, is that equal to 6 over 7? And you can go about this a couple of different ways. We know that 3/5 is reduced, 6/7 is also reduced, and because neither of those fractions reduce any further, we can say right away that this is false. You can also use the cross product property to cross multiply these two ratios to determine if the extremes are equal to the means. So what we would have here would be 3 times 7, which is 21. Is that equal to 6 times 5, which is 30? In fact, it is not, so this one would be false. On number 2, we have 7/11 equal to 8 over 12. 7 over 11 does not reduce. 8 over 12 does reduce. They're both divisible by 4, so we get 2 over 3. And you can see that since both ratios are reduced, they are not equal. We can also check, like we did in number 1, by cross multiplying to see if in fact these ratios are equal. So we would do 7 times 3 equal to 11 times 2. 7 times 3 is 21. Is that equal to 2 times 11, which is 22? In fact, it is not, so this one's also false. And for the last example, number 3, we have 4 over 6 equal to 6 over 9. So both of these reduce. On the left, 4 and 6 are divisible by 2, so we get 2 over 3. And 6 and 9 are both divisible by 3, so we get 2 over 3. And you see here we do have ratios that are equal, so this would be true. If you cross multiply, you would have that 6 equals 6. That's also true. In examples 4 and 5, you're asked to find the missing term. So we have x over 7 equal to 9 over 11. We know that the product of the extremes, which would be 11x, is equal to the product of the means. 9 times 7 is 63. We need to divide both sides by 11. And 63 divided by 11, it doesn't go in evenly, it is a fraction, so we're just going to round the decimal. It's 5.72 repeating. On example 5, we have 3/5 equal to 15 over A. So when we cross multiply, we have 3A equals 75. Divide both sides by 3, and we get that A equals 25. So those are some pretty simple cross-multiplying examples using the cross-product property. Again, in example 6, we have 6 over m equals 7 over 8. So we do 6 times 8 and set it equal to 7 times m. So we have 48 equals 7m. Divide both sides by 7. 48 is not divisible by 7, so we will round again. It's 6.857. If we round to 2 decimal places, you get 6.86. And in example 7, we have 4/5 equal to c over 25. So again, cross multiply, we get 100, 4 times 25 equals 5c. Divide both sides by 5, and we get c equals 20. Okay, a few more examples left. These are story problems or word problems. And we're going to use the ideas of ratios and some things we've learned before in geometry to help us solve these. So for example 8, we have the ratio of the measures of 3 angles of a triangle is 2 to 3 to 5. Find the angles. And what that ratio represents is that 2 parts of the total measure of the angles, 3 parts of the total measure of the angles, and 5 parts of the total measure of the angles are what each angle represents. So if I draw a picture of a triangle here, we have 2 parts, 3 parts, and 5 parts. That's how we, because x is going to be some number, so that means that the ratio is 2 to 3 to 5. So if we add up these numbers, 2x plus 3x plus 5x, we get 180. We know that the angles of a triangle add up to 180, so we take the 2 parts plus the 3 parts plus the 5 parts to get 180. These are like terms, so when we combine like terms, we have 10x equals 180. Divide by 10, and we get that x is 18. We were asked to find the angles themselves, so we can't stop here. We need to plug 18 in. 2 times 18 is 36. 3 times 18 is 54. And 5 times 18 is 90. So we get the 3 measures of the triangle, 3 measures of the angles to be 36 degrees, 54 degrees, and 90 degrees. If you want to check, you can add those 3 numbers up, and you do get 180. Another example using ratios. The ratio of the measures of 2 supplementary angles is 4 to 5. So that means 4 parts to 5 parts. Find the angles. So if one of the angles is 4 parts, that's 4x. The other angle is 5 parts, that would be 5x. And if they are supplementary, that means that they add up to 180. We need to solve for x. So we have 9x equals 180. Divide both sides by 9, and we get that x equals 20. Again, you were asked to find the measures of the angles, so we need to plug the 20 back in. 4 times 20 is 80. 5 times 20 is 100. So the 2 angle measures are 80 and 100, and if you add those up, you do get 180. So those angles would be supplementary. The perimeter of a rectangle ABCD is 60 inches. The ratio of AB to BC is 3 to 2. Find the length and the width of the rectangle. So the first thing we're going to do is draw a rectangle, and we're going to name it ABCD. Remember, you just start in a corner and work your way around. Some things we know about a rectangle: all of the angles are 90 degrees, and also opposite sides are congruent. Now we have the ratio of AB to side BC is 3 to 2. So AB would be 3 parts, BC would be 2 parts. And since we know that opposite sides are congruent, we have 3x and 2x for sides CD and DA. The perimeter is 60. That's going to help us solve for x. You know that the perimeter means the distance or the lengths all the way around added up. So we have 3x plus 2x plus 3x plus 2x equal to 60. If we combine like terms, we have 10x equals 60, or x equals 6. You're asked to find the length and the width. So we would have 3 times 6, which is 18 for the length, and 2 times 6, which is 12 for the width. And we should put a unit on there of inches, and that's your final answer. The last example is with side lengths of triangles. So the ratios of side lengths of triangle DEF to the corresponding side lengths of triangle ABC are 3 to 2. Find the missing lengths using the given picture. And symbolically what we have here is that triangle DEF is similar to triangle ABC, which means they are the same shape, not the same size. And that's given in the ratio. The ratio of the lengths of the sides is 3 to 2. So that means that triangle DEF, that's the 3 part, triangle ABC is the 2 part. So in order to find the missing lengths using the given picture, you see we need to find x, y, and z. We're going to use the similar parts of the triangles to compare those to the ratio 3 to 2. So if we start with x, x is side length DE, and it is similar to length AB. So if we take x over 6, we know that the ratio of those side lengths is 3 to 2. So we're going to cross multiply. 2x equals 18, and x equals 9. So we have a 9 here for DE. We also need to find y. We aren't going to use what we found for x. In case you make a mistake, you want to make sure that you're still using the ratio of 3 to 2 versus setting up this next example using 9 and 6. So in order to find y, that's side EF. It is similar to side BC, which is 8, and the ratio of those side lengths is 3 to 2. So again, we cross multiply. 2y equals 24, and we get y equals 12. And finally, to find z, z is similar to DF. So, and you have to be careful here, make sure you're setting things up in the right order. If DF is 6, that's going to go on top because it's the ratio of DEF to ABC. So we have 6 over z equal to 3 over 2. When we cross multiply, we get 12 equals 3z. Divide both sides by 3, and z equals 4. If you want to check your answers, just set up the similar sides as a fraction and then reduce to see if you get 3 over 2. So the first answer, DE and AB, that's 9 over 6. That does reduce to 3 over 2. EF and BC, that's 12 over 8, which also reduces to 3 over 2. Both numbers are divisible by 4. And then finally, DF to AC would be 6 over 4, both divisible by 2, so it does reduce to 3 over 2. In class, we're going to work on a book assignment, so please make sure you have your textbooks with you, page 461 to 464, 10 to 13, 25 to 47, 54 to 56, and 68 to 72.